Today we're going to be talking about corresponding parts of congruent triangles. Our objective is that we will be able to use congruent triangles to prove that corresponding parts are congruent. So let's review. Corresponding part are pieces in the same relative place in a figure. So, if we know that two triangles are congruent, the conclusion that we can make is that the corresponding parts are also congruent. So if we look at triangle PQR and we are told that it's congruent to PLM, we know that that all of their corresponding parts are congruent. So we know like angle R would be congruent to angle M. Or that side RQ is congruent to side ML. And we could do this for every angle and every side. But let's focus on the proofs. So, given that HI is congruent to HK and that HJ bisects IK, prove that angle I is congruent to angle K. So, we always start with our givens. So, we're given that HI is congruent to HK. And we know that because it's given. So, I'm going to mark that on my picture. HI and HK. Then we were told that HJ bisects IK. Reason being, it's given. So if HJ bisects IK, we know that IJ must be the same as JK. So IJ is congruent to JK. And we know this because that's the definition of bisect. So right now we know about two angle pairs. So we either need to find, two side pairs. So we either need to find that a third side is congruent or that angles are congruent. Well, we weren't given any information about angles, so let's go with sides. Because they share this side, HJ, we know that HJ is congruent to HJ, and we know this because of the reflexive property. So now we have enough information to prove that the triangles are congruent by side, side, side. So triangle HIJ would be congruent to triangle HKJ. And since the triangles are congruent, we know the parts are congruent. So angle I is congruent to angle K. And the reason for this is corresponding parts of congruent triangles are congruent, or we can shorten that by CPCTC. So basically these proofs are the same as the ones you've been doing the last couple classes. We're just adding on one more step at the end. Let's try another one. Again, start with your givens. So angle B is congruent to angle E. Reason being that it's given. And then let's mark it on our picture. Number 2, FE is congruent to BC because it's given. So FE is congruent to BC. FE is also parallel to BC, again, because it's given. So we do the little arrows on the lines to show that they're parallel. So the parallel one is going to be the given that helps us with the most information. Because right now we have angle and side. So it's either got to be angle, angle, side, or angle, side, angle. So regardless, we need a second angle. So I'm going to extend these lines that just said they're parallel, because it'll make it a little bit easier to see. And then here we have this transversal going through. So it's like the things we did in our parallel unit. So if you look, we have alternate interior angles, either those, yeah, those right there, alternate interior angles. So we can say that angle F is congruent to angle C because they're alternate interior angles. So now we have angle, side, angle, angle, side, angle. So we know triangle BCA is congruent to triangle. Make sure you match up your markings with the order of the letters. So B and E, C and F, and that just leaves D. And they're congruent by angle, side, angle. Now that the triangles are congruent, we can prove that the other pieces are congruent. Angle A is congruent to angle D by corresponding parts of congruent triangles are congruent. One last proof. Given that TM is congruent to MR and that JM is perpendicular to TR, prove that JT is congruent to JR. So again, start with our givens. M is congruent to MR, and JM is perpendicular to TR. So, because these are perpendicular, we know that angle JMT is congruent to triangle JMR, and they both equal 90 degrees because of the definition of perpendicular. So let's draw that in. So we have a side and an angle, and then we know this other side is congruent. JM is congruent to JM because of the reflexive property. So now we have side, angle, side. So we can say triangle JMT is congruent to triangle JMR by side, angle, side. And therefore, JT is congruent to JR because corresponding parts of congruent triangles are congruent. For your summary, How do these proofs compare to the proofs we've completed in the last couple of classes? Fill in your summary, and I'll see you in class.